All right, today we're going to explain the Huawei HCIE-Datacom LAB exam. Now, let's look at the overall project requirements. In this video, we'll mainly cover how to fulfill some of the requirements in Section 1. Currently, the HCIE exam is divided into 4 sections. Sections 1, 2, 3, and 4. We will have videos later on that specifically explain the content of the other sections. For now, we are first recording an explanation of the content for the first section. If you are interested in the HCIE-Datacom LAB exam and would like to get study materials, you can leave a comment below my video. Once we see it, we will reply to you as soon as possible. All right, let's officially begin our introduction to Huawei's current HCIE-Datacom exam. Overall, it's a major exam version, and within it, we need to complete a real-world project requirement. Today, we'll start by giving a brief introduction to this requirement. Now, let's talk about the 4 modules it's divided into and what each part corresponds to. In the exam, what you'll need to complete is, as shown in the diagram here, the entire topology configuration. The devices involved are exactly those displayed in the diagram. These are all the devices you'll be working with. In the overall exam modules, we have divided everything into 4 sections. The devices mainly involved in the first section are located in this area. This is the first part. The devices involved in the second part are mainly in this area. Later, when we get to the breakdown section, we'll discuss the requirements in more detail. The third part mainly involves devices in this area. This is the third part. As for the fourth part, it is located here. In the first part, we have included, that is, here there is a Python script to execute a segment of code for project inspection. So this is the fourth part. For all 4 modules, we will later have corresponding video breakdowns to explain the different content of each module. So today, we'll start with the far left, which is our first part, and begin our explanation from there. Before we get into the specific technical requirements, you need to have a basic understanding. What exactly is this diagram asking us to do and whose devices are represented here? Now, let's say as engineers, you've joined a company. When this company first started, it was relatively small in scale. At the very beginning, the company was just this size. This was the prototype of the company. As the company grew, it added a second office building. The devices on the right side of our diagram represent the equipment that will be added in the future. So as the company expands, new equipment is introduced. We merge the new equipment with the old network, integrating them into a new network. As a result, there will be new project requirements. So everyone needs to upgrade our network to accomplish the first part of our task. This part is carried out entirely through our current CRM command line interface, which means you'll need to debug and configure the equipment using command line operations. Later, when we move on to study the second part, that section will be based on SDN, where automated configuration and deployment are carried out through the controller. That's a different approach. For our current assessment, the vast majority of the commands are included in this first part. So that's the introduction to this part. Now, this section in the middle represents our carrier, of course. This is the network of our telecom operator. This part here is the enterprise, currently located in another city called City Y. Its headquarters are in City X, and City Y is a branch serving as their production and R&D center. Nationwide, they have a large number of pilot stores, all connected through the telecom operator. This here is their data center located in City Z. So within the entire network, this serves as the company's headquarters, its branches, and one of the many pilot stores across the country. And this is, as we said, the company's data center in City Z, connected through the telecom operator where certain business interactions are carried out. This is our third section, and we'll cover it in more detail in future videos. Now, let's continue. Within these overall requirements, we will have, there will be some basic introductions here where we'll explain the network upgrade and transformation and talk about the project background. As I mentioned earlier, the previous network structure was like this. We had 2 access points, 1 AP, a stacked aggregation switch, a stacked core switch, 1 AC, and at the exit, dual lines connected to 2 different ISPs. After the network restructuring, in other words, once your network has been upgraded, we need to make it look like this in order to integrate various requirements, help you expand your needs, and meet the demands of the new projects. In the future, during the exam, all these diagrams will be provided to you, including the corresponding device interfaces. For example, in the lower right corner, some devices do not have interface numbers. In such cases, you will need to configure LLDP on the devices to check the interfaces of connected devices. This is a basic introduction to the requirements we are dealing with. Now let's start introducing our actual requirements. There are actually several requirements within the overall task. Some of these requirements can be achieved using simulator software, such as Huawei's ESP. We won't cover those today. In this demonstration, we'll focus on requirements that can only be met by configuring actual physical devices on our rack. We'll do a brief demonstration of these in class. We'll do a simple demonstration, but that doesn't stop us from first discussing the overall requirements. All right, let's get started. The first point is about some of the basic services in our current network. You'll need to plan out the services for different departments and then distinguish which VLAN each department uses for access. So, what should the VLAN address pool and VLAN pool be named? Which devices will serve as their gateways? Also, how will the IP addresses be obtained, and what is the allocation mode? These are all part of the basic initial configuration according to the requirements, so you just need to configure them based on this. All right, in the future, if you need to type out the commands again, we will provide everyone with the complete set of questions, so you can just follow this sequence to complete the exercises. Moving on, we'll be doing some basic network segmentation. On the core devices, we'll set up some VPN instances to separate our internal and external visitors, and we'll also do some basic configurations on the firewall. Yes, to connect our services, including some wireless services, we need to do some wireless expansion, because in this process, as we mentioned before, we only had one AP, but now after adding some new ones, there will be an extra AP, so here we need to carry out some expansion. Next, we have some requirements for the network's current outbound connections. For us to access the internet, we need some basic configurations like static routing and NAT settings. These are our fundamental requirements. Moving on, what I'll be demonstrating for everyone in class today is the access part, specifically our access authentication. You can see that this section carries a relatively high proportion of the total score, while the other sections, comparatively speaking, don't account for as many points. Network isolation carries a high weight because it involves much configuration. One of the most critical aspects is access control. Many enterprises now require this. Whether wired or wireless users connect, access control is needed. We'll detail the requirements and configuration for this soon. All right, let's finish discussing the rest. There are still some network security requirements below, as well as implementing some security policies on the firewall. Finally, we need to verify some of the results involved. So for us right now, these are the complete set of items we've covered above. Yes, the requirements for the first part. In today's class, we're demonstrating this section. We'll be showing some basic command line operations, which you can't practice using local simulators, so we'll mainly focus on these. These are commands that, compared to what you usually encounter, you can't access on your own local machines. All right, before we get into the explanation, let me first introduce this. In the future, if you practice using our rack, you'll log into our exam machine. After accessing the desktop of our exam machine via RDP on our desktop, you'll need to open this mobile system. I've already opened it here in advance because I did some device restoration. Let me close it and reopen it. This is the tool currently used in Huawei's exam environment. The connection tool we're using now is also this mobile item. After you double-click to open it, you'll see a list on the left. In the exam room, all these devices have already been connected for you in Huawei's server room. You just need to open these devices through Huawei's cloud desktop to configure them, so there's no need for you to connect them manually. It's the same here as well. For today's access authentication, the devices involved, we'll just select a few here as examples, specifically between our access and aggregation layers. We'll go into more detail about this later. For now, I only need to open 3 devices, so I'll use these 3 as examples. I won't look at any more than that. On the left side of the list are some of our devices. Just like in the exam room, we've already set up these connections in advance, so once you log in, you can operate them directly. Some of the devices may have already been manually restored by others. Before this, I cleared out some of the basic configurations set by the previous student so it won't affect the configurations we're about to do here. Once we're in, we can start configuring the devices in batches. The devices we'll be using are 2 ACC access devices in the T1 building. One is the aggregation device, the AGG. Let's take a look at the requirements. All right, let's go through the requirements document. In our access authentication module, we need to ensure the end-to-end security of our network. So we need to, within the company, besides, let's draw a diagram, shall we? For example, this is our current topology. In this topology, your future clients or your internal office users or some external wireless users will be connecting in. We also have some guest services accessing the network. So what needs to be done at this point? We need to implement some basic access control, right? But before we do access control, we first need to verify the identity of the clients. This is the necessity of our access authentication. So what we're doing here is essentially requiring all the internal company endpoints, whether it's a wired endpoint like terminal 01 or 02, or a wireless endpoint like terminal 05, to undergo authentication. In other words, within the company, all endpoints except for the servers need to be authenticated. All the remaining devices must be authenticated before they can access the network. This is the main task under our requirements. Now, for wired endpoint access, since it's a PCA, what we're using here is 802.1x install authentication. Here, we need to deploy several policy linkage functions, including a number of basic authentication configurations. In addition to that, as part of this process, we will also ensure that all necessary settings are properly reviewed and implemented. For example, devices like printers or commonly used IP phones within the company aren't shown in this diagram, but they are part of the requirements, as I mentioned to you. That means there are some subterminals here that don't support this type of authentication. So what do we need to do? We have to use other authentication methods. For our current setup, the aggregation and verification, together with our authentication server, will interact using the Radius protocol. In other words, from here on, we will be performing authentication interactions with our server. Now, you don't need to configure the server part yourselves. These are pre-configured settings already in place, so you don't need to do anything manually. Here, we will have a corresponding server address, which is your 3A server. Currently, Huawei uses its Azure controller product to implement this. However, you won't have access to this part during the exam. This section is pre-configured in advance, and its address is set here as 10.1.60.2. This is its address. We use its default port number for authentication. Authorization and billing, that is Huawei's product. When we talk about this as a product in the entire authentication module, it has some default ports. We'll see these when we do the configuration later, and I'll mention to everyone that we'll be dealing with ports 1812 and 1813. In addition to that, there are actually restrictions on our keys as well. Currently, in all of our Huawei exams and assessments, all device keys are set to Huawei at 123. Whether it's the device's own login keys or the keys used for device encryption and authentication, all the passwords we use are like this. So throughout the entire lab exam, the passwords you need to enter are unified. They are all this same password. In addition, we also have certain definitions for naming, such as employee, and we also have corresponding authentication domains. Here, there are distinctions between uppercase and lowercase letters, which means we do not allow access using other domains. Besides that, our current Radius server issues user VLAN information based on the name of the VLAN pool. So for this table, everyone can just refer to the table above. That is, we have some corresponding tables here, and when we provided them earlier, we gave them to everyone. For example, here we have a table like this. This is our table 1-1. The same goes for the exam. It will prompt you under this requirement to refer to which table. Just use it accordingly. So this is a reference for our tables. In addition, for all our current AP devices, you need to check the AP's MAC address, and then you need to force it to this. We mentioned that the AP authenticates in the domain where AP authentication is not required. Here, the authentication mode is NaN, which just means it's empty. So this requirement is more decorative or symbolic, but you still need to configure it. In addition, for the following part, the users, their information, and corresponding authorizations have already been configured on our server, which is equivalent to having the corresponding pre-provisioning in place, so we don't need to configure it again. As for the password information, regardless of which department it is, the passwords are unified. That means after users gain access through the terminals below in our Windows environment, you will use your account and password. That's how it works. The corresponding username and password. After passing the access authentication in the future, we can proceed to run operations. Once this operation is authenticated, the results will be covered in the fourth part. Before I record that video, I'll make sure to set up this configuration in advance. So at that time, I'll show everyone a segment about executing a Python script in the terminal after successful authentication. We won't spend too much time on this part when explaining the requirements. All right, let's do a basic demonstration of the requirements here. All right, let's get started. In the part where we do access authentication, the configurations involved are for our two access devices. These two ACCs are actually just these two devices of ours. Yes, it's these two devices. Let me scroll up a bit. What I'm showing you now are these three devices. Among them, ACC1, ACC2, and our AGT1 are all located in our T1 office building. So in a moment, we'll be doing some pass-through configuration on these devices. Also, we need to perform some configuration and deployment for our current Radius server on these devices, including the authentication information for page 3A, so let's get started. First, let's go to... Let me enlarge the text a bit, just a little, so it's easier for everyone to see. Sometimes in the exam room, you can do things in batches or open multiple windows at the same time to configure. For example, if I need to configure two access points here, and some of their configurations are similar, you can open these two windows here and configure them together. So, what do we need to do first? First, under the global configuration, we need to configure dynamic transparent transmission for these two access devices. Here we are dealing with LTP, and in this section, the protocol. After entering the commands, here we have the corresponding user, the user-defined protocol. All right, in this section, you need to write this manually. Keep in mind, when distinguishing scripts in future exams, there are some commands that you might not be very familiar with. You can use the tab key to autocomplete a few times during your first operation to take a look. That is, if you've worked with these technologies before, You might be relatively familiar with them. If you haven't, you'll need to get used to it as you type. This is how we configure things in the command line. So in this process, we need to add our fixed protocol. This is a fixed value. Here we're using 0180. You can find these in the relevant documents in Huawei's exam environment. However, it's generally recommended that you can make a note of this MAC since it's a universal one. After we've finished the above configuration, here we need to set it as a group MAC. After setting the group MAC, we write it as 01000000. Then, after entering 0002 and pressing enter, that's our first step. In other words, we now need to enable the basic transparent transmission function accordingly. After finishing this, we need to go into the device and access the relevant instruct interface. For example, enter instruct interface 1. Some device configurations here need to have been pre-configured, meaning that under this interface, there are some preset configurations. So some of these pre-configurations actually need to be modified according to the requirements in the earlier part. For example, here, we also need to make some mode adjustments. In fact, under these two interfaces, the configurations will ultimately be made consistent by me. It's just that here I haven't implemented the earlier requirements, I simply restored the rack to the pre-configured state. But this doesn't affect our ability to execute the commands we'll be running next. It doesn't have any impact. Alright, let's write this out here. It's the same for our current interface as well. After we receive this message, how do we handle it? We need to do the same thing. Use a user-defined protocol, which we call docket. This is the same here. Note that in this case, .cha is a name we manually assigned ourselves. Enable. After enabling it, we enter the corresponding interface on the device. In theory, for these access switches, you need to configure from port 1 to port 20, because in the future, users might connect through any of these ports. This will be specified in the requirements. So on the device, you can use interface range. What do we innovate here? It's the interface range command. Here we can simultaneously enter the device's G0/0/1 interface all the way to G0/0/20. This is a command that can't be executed in Huawei Simulator ESP. It's called interface range. We go from port 1 to port 20. After entering, it's equivalent to being in the configuration mode for all 20 ports. Then we apply the same pass-through command as above. Our port 1/1 is the uplink interface that connects to our aggregation switch. This is our uplink and this is our instruct. The downlink, which connects to our terminals, is from port 1 to port 20. So in fact, we need to enable the corresponding .1H transparent transmission on both the uplink and downlink interfaces. This is the first function we want to achieve. Now, when we have 4, let's say 4, although in the diagram we only demonstrate with 2, in reality all 4 basic switches are configured the same way. Here we just use these 2 for demonstration. After configuring them, we need to proceed to the device to make the corresponding configurations. Which device? It's our current aggregation switch. Once we get to this device, we need to configure the radius server and authentication settings. So let's take a look. First of all, we need to do this part here. All right, first we need to configure our authentication server here. The first step is to set up a basic template. Our template is called employee, which was actually mentioned in our earlier requirements. So just follow the requirements and type it in accordingly. After creating the device, of course, some prompts will pop up. During the exam, it's not recommended to turn off the logs. Here, for our radius server, we need to set a shared key and configure it. For security, we'll use an encrypted password, which is Huawei@123. This is done entirely according to the exam requirements. In addition, for our radius server, in the authentication section, we need to specify the corresponding port number, right? Here, we need to configure our current ALI settings, which is 10.1.260.2, as we saw in the requirements earlier. The port we are using here is 1812. In addition, we also need to configure another port for it, which is the accounting port. The configuration here is the same as above, only some parameters are a bit different. For accounting, it's 10.1.60.2, and for 10.10.1.60.2, the port is 1813. That's the content for this part. Moving on, let's go back to the global configuration mode. Here, we need to set up different commands, and it's important to configure the overall mode properly. This is something everyone should pay attention to. It's something that's easy to overlook. Here, for authentication, we configure 10.1.60.2, and then we set a shared key. It's the same as before, Huawei@123. So, this module here is the configuration for our current radius server. Now, besides this, we also need to do some AIA configuration for authentication. So what do we configure authentication? Here we do some configuration, write a template for our employee, and set it up accordingly, based on the requirements of our exam. I've already introduced the requirements document to everyone earlier, so I won't go over it again here. Our authentication mode is the radius mode. Then, coming back to this point, the commands I've just entered above can actually all be implemented in the simulator. There are some commands that can't be executed, and I'll explain those to you in detail in a bit, right here. Now let's go back and look at another term here, which is authorization. The template here is the same. We'll write employee for it. During the exam, you can also execute some scripts for these steps, meaning you can use some text editing software to batch configure settings and then push them to the device. For our demonstration here, we'll be typing everything by hand, so the progress will be a bit slower. Progress will be relatively slow this way. It's the same here. We need to select the corresponding mode for it. This mode is called None, which you could see earlier in our requirements. Finally, we have Accounting. Here as well, it's also called Employee, still Employee. Once inside, our accounting also needs to be configured. The mode here is radius. Alright, so that's the part we've just covered. Actually, you can also use the simulator to enter commands. In the future, when you're entering commands on the T1 aggregation device, you can also do the same on the T2 aggregation device. Both devices can be operated together. That's what this part is about. In addition to that, we also need to make some extra configurations within the device, specifically in our domain, in the employee domain. So let's exit out of here, and in this section, we go to our domain. Employee, this is the one we just talked about. Here, you also need to complete the configuration. After entering, we need to specify accounting and authentication here. We need to set them up and make sure all the templates are set to employee. The first one is authentication, and we set it to employee. Next is our accounting section, which remains the same as before. We write the accounting information here, and its template is also set up right here. Finally, there are some other aspects involved here, and it's the same process. Employee. This is the creation we just completed, and you can take a look at it. Besides the creation I just did, the radius here is also the same. Our server is also set to employee. All right, once we've finished this part, our 3A configuration is complete. Next, what we'll mainly do is configure MAC authentication and set up the authentication template for port-based access. Since we can't enter commands in the simulator for this, we'll demonstrate these commands in the global configuration mode. The first step is to go to the port configuration. Access. This is our current access template. We'll give it a name. Let's call it employee. Yes, it's called employee. This is what we refer to as the first step, which is creating our current access template. After creating it in the global configuration mode, we also need to create another template for it, which is the MAC template. MAC, we call this the access profile. Internally, it's the same for us. It's also employee. For these frequently used terms, you can just copy them. Here you can actually paste as well. In an exam environment, it's recommended that you use copy and paste more often. That way, when you have to enter the template multiple times, you're less likely to make mistakes. So create an access template. This is for our subterminals to use. And finally, we also need to create some authentication templates globally, such as this authentication. Profile, let's also give it a name, and its name is also employee. Let's attach employee here. After employee, once we've created the authentication template, we associate the .1x access template here. We call it the .1x access profile employee. Then associate the MAC access profile you just created as well. In other words, link your MAC access template to employee too. In addition, here we need to create an access domain to strictly enforce that we currently belong to the authentication domain of this employee. So we specify here access domain employee false. This is our way of enforcing the authentication domain. Finally, we need to enable MAC bypass authentication to provide some corresponding support for our subterminals. Right here we call it MAC bypass. These are some of the configurations related to MAC and authentication templates on the device we're dealing with. Next, regarding the 2 downlink ports on our current device, when we were configuring earlier, we were actually working on the uplink ports of these 2 devices. These are the 2 ports where we set up pass-through, remember? And for the interfaces numbered 1 to 20 below, we also configured pass-through. Now this is the device below, and the device above it also has some ports. Port 1 is interconnected with the device above, while ports 2 and 3 are connected to the devices below. So ports 2 and 3 will also have corresponding configurations. We'll demonstrate their configuration here. This is also something you can't try out directly on the simulator, so we'll show it here for ports 2 and 3. So using the intervis instruct command for port 2 actually on the device right now, we haven't finished creating this instruction, but that doesn't affect us entering this part of the command. We just need to type employee here. Similarly, we enter E3, and for port 3, we also enter this command in the same way. You need to call this authentication template on the downstream interfaces of your aggregation device. Once you've finished calling it, actually, this part is already half done. In addition, we also need to configure the AP authentication exemption information. In the 3A environment, we enter authentication, and here there is a template. Why do we need this? It's for the APs that don't require authentication, which we call AP no auth, right? Here we create a corresponding template for it. This is just a name, and it's set according to our requirements. It's called AP no authentication. So, after we configure AP authentication exemption, we specify its mode here. What is its mode? Its mode is NAN. So here we say yes. Yeah, let's execute this command. Besides that, we go into our current AP no authentication, which is called AP no OS. It's the same here. You need to define this name yourself. However, Huawei has specific rules for naming, so just follow their rules when you set it up. Here we also apply this template. All right, after linking it to our APINO, once the association is complete, this step is successful. In other words, we use our MAC to configure AP no authentication above. Below, we use the MAC to do what? To force the corresponding AP into the AP no authentication domain. Actually, there are some differences in this configuration. So where do you check the MAC addresses of these APs? You need to check them later on the AC device. That's all. I won't open it up here. As for the AC device, in the future, you can use the display command on the device. For example, here, later on, you can execute this display command on the AC. So display AP, or you can check its AP, and then you can see the AP's ID, right? After the AP's ID, you'll see the AP's MAC address. You might see two MAC addresses because the AP has a corresponding name, so you can see that. Which AP is connected from where? For example, we say that the APs on this side are connected through age here, and the APs on that side are connected through age 2. So based on the AP names, this one is called the TE-AP, and that one is the T2-AP. You can see the corresponding MAC addresses. So on this device, you just need to enforce the corresponding MAC address. That is, by using the MAC address, you can force this AP into our AP's unauthenticated domain. Let me briefly explain the command. In the device, we won't look at the final result because for access authentication, you need to have your services configured in advance, and after your addresses and VLANs are all planned and set up, only then can you see the effect. We can't demonstrate the final result here. We'll demonstrate the direct effect later when we get to section 4 on Python. For now, let's just talk about the basic command, which is called domain. Here in the domain, we enter the AP's APINO, which is what we just worked on. Then we're mainly going to demonstrate a command called false, where we perform a corresponding enforcement. What is the enforced MAC address? For example, earlier you saw that the AP here is called XXXXXX. This is the command used in Huawei devices. For MAG, this is how it's displayed. Then here you enter the mask, and in this field, you just fill in F. Of course, in this context, the corresponding command is incorrect, so if you type the following command, it won't work. Here, I'll just enter something at random, like 4422. So for example, something like 7C08, and then let's say E420, just picking something at random. Here you can see that if you enter the mask like this with these X's, it won't fill in completely. You have to follow its command format to adjust it, so here we select F. Here, after you finish executing, based on the different AP MAC addresses below, you just need to force them to authenticate in our AP's unauthenticated domain. Actually, authentication here is bypassed, but you still need to follow this process, so you need to configure it accordingly. At this point, you can just press Enter. In the exam, you would check the AP address on the AC, but here I'm just demonstrating. These are our basic configurations for access authentication. What I've mainly shown you here are these configurations, and you can enter all of them normally on our devices. The environment in our exam room is also a restored version of this scenario. So the way you practice entering commands is exactly how you'll do it during the exam. Of course, entering commands isn't the most important thing. The most important thing is that the results you get are correct. In the future, within the X campus, there will be